Hello everyone, welcome back to the channel. In today's video, we're going to learn one of the most important operations when working with databases, the select operation in Spring Boot. We'll see how to retrieve data from a database using Spring Boot with the help of JDBC template. By the end of this video, you'll clearly understand how to write queries, map the results to Java objects, and display them in your application. So, whether you're just starting out with Spring Boot or preparing for a project, this video will give you a solid understanding of how to fetch data effectively. Let's get started. We are going to start with the select operation, and the very first step for that is creating our model class. The model represents the structure of our database table inside our Java application. Here, I am creating a new class called employee inside the com.demo.model package. Now in this class, we will add variables that represent the columns of our database table. After declaring them, we'll generate the necessary getters and setters, as well as constructors, so that Spring Boot can easily map the data between the table and our Java object. Before we start writing code for the select operation, let's first take a look at the database table that we'll be working with. Here in MySQL, I have a table that stores employee details. This is the table on which we'll perform our select operation. By checking the table first, it becomes clear what data we already have and what columns we need to fetch using our Spring Boot application. Now that we've seen the table, let's move back to our project and start implementing the select functionality step by step. Now, let's move back to our employee model class. Here, I am declaring the variables that represent the columns of our employee table. Each variable corresponds directly to a column in the database. Once the variables are declared, the next step is to generate a constructor so that we can easily create objects of the employee class when needed. After that, we also generate the getter and setter methods. These methods allow us to access and update the values of the variables in a clean and object-oriented way. With this step completed, our employee model is fully prepared to hold data that we'll fetch from the database using our select operation. Now that our model is ready, let's create the three main layers that make up our Spring Boot application. First, I'll create a new class called MyRepository. This layer is responsible for directly interacting with the database. Here, we'll write our SQL queries and use JDBC template to execute them. Next, I'll create a MyService class. The service layer acts as a bridge between the repository and the controller. It handles the business logic and calls the repository methods whenever data is required. Finally, we create the MyController class. This is the entry point for the user. Whenever we make an API call, the request first comes to the controller, then goes to the service, and finally the repository, which talks to the database. So in summary, controller handles requests, service processes the logic, and repository communicates with the database. With these three layers set up, our application follows a clean and structured MVC design. Now, let's go ahead and write the code for our repository layer. Inside the MyRepository class, I am first using the @repository annotation to tell Spring that this class is a repository component. Next, I am injecting the JDBC template object using @AutoWired. This will allow us to run SQL queries directly on the database. After that, I create a method called getData. Inside this method, I've written a simple SQL query. Select * from EMP. This query will fetch all the records from the employee table. Finally, I return the result using JDBC template.queryForList SQL. This method will execute the query and return the data in the form of a list of maps, where each map represents a row from the table. So with this, our repository layer for the select operation is ready. Now that our repository is ready, let's move on to the service layer. Inside the MyService class, I am first adding the @service annotation. This tells Spring that this class is a service component, where we handle the business logic. Next, I inject the repository using @AutoWired. This gives the service access to all the methods inside our repository. Then, I create a method called getData. Inside this method, I simply call repo.getData and return its result. This way, the service acts as a bridge. It receives the request from the controller, calls the repository to fetch data, and then returns the result back to the controller. So with this, our service layer for the select operation is complete. Finally, let's create our controller class to expose the select operation as an API. Inside the MyController class, I use the @RESTController annotation. This tells Spring that this class will handle HTTP requests and return responses in JSON format. Next, I inject the MyService class using @AutoWired. This gives the controller access to the service methods. Then, I create a method called getData. I map this method to the endpoint/employees using the @getMapping annotation. Whenever a request is made to /employees, this method will call the service's getData function, which in turn fetches all employee records from the database. The result will then be returned as a JSON response to the client. Before testing our select operation, let's first create a simple Hello API to make sure everything in our project is running correctly. Inside the MyController class, create a new method called hello. Use the @getMapping/hello annotation to map it to the /hello endpoint. In the method, simply return a string like hello world or API is working. So whenever we access http://localhost 8080/hello in the browser or Postman, we should see the message returned. This step ensures that our Spring Boot application is running properly before we move on to the select operation. Open Postman and create a new GET request. In the request URL, type http://localhost 8080/hello and hit send. If everything is set up correctly, you should see the response message hello world or API is working in Postman. This confirms that our Spring Boot application is running properly and the route is working. Once this is verified, we can move forward and test our /employees select API to fetch data from the database. Now that our test/hello API is working, let's create the real API to fetch employee data from the database. Inside the MyController class, create a new method called getData. Use the annotation @getMapping/employees to map this method to the /employees endpoint. In this method, we simply call the service layer's getData method. The service layer, in turn, calls the repository to fetch all records from the employee table. When a request is made to /employees, it will return all employee data in JSON format. This completes our select operation API, and now our Spring Boot application can fetch and display data from the database. Now that we have created our /employees API, let's build and run the project to see it in action. In NetBeans, right-click on the project and select Clean and Build. This will compile the code and download any required dependencies from Maven. Once the build is successful, right-click on the project again and choose Run. The Spring Boot application will start, and in the console, you should see the message running, which confirms that the server has started successfully. With the application running, we can now test our /employees API to fetch data from the database. Now that our application is running, let's test the /employees API in Postman. Open Postman and create a new GET request. If everything is set up correctly, you should see a JSON response containing all the employee records from your database. This confirms that our select operation is working properly, and the flow from controller service repository database is functioning as expected. Now our Spring Boot CRUD application can successfully fetch and display data from the MySQL database. That's it for this video. We've successfully created the employee model, built the controller, service, and repository layers, implemented the /employees API to fetch data from the database, tested the API in Postman to ensure it works perfectly. In the next video, we'll move forward and implement the insert operation to add new employee records into the database. If you found this video helpful, don't forget to like, share, and subscribe to the channel for more Spring Boot CRUD tutorials.